This video shows how to use TuneWizard to tune a control loop. When you install the software, you get two icons on your desktop: the TuneWizard icon and the Process Simulator icon. The Process Simulator allows simulation of different types of loops and can be used in place of a real process. For the purposes of this exercise, let us choose a flow loop and let us place the controller in manual mode. The TuneWizard icon is used to start the control loop tuning program. The tuning process involves a number of steps. We need to specify the control loop to be tuned. We need to specify the type of PID algorithm which is used in this particular control loop. In addition, we need to specify how to obtain process data. We can use a DDE or an OPC connection. We can obtain data which has been stored in a CSV file. Or we can use the built-in process simulator to obtain process data and experiment with the TuneWizard. Let us now collect process data to tune this flow control loop. In general, we can use process data to estimate hysteresis and stiction for the control valve. Also, we can calculate process nonlinearity and variability. To start the data acquisition process, we click here, and by checking this box, we start the data collection process. We can change the time frame of this plot. Let us use 2 minutes. The controller is already in manual mode. We can change its output to 45% and see how the process responds. Here is the change in the controller output. The blue line shows how the process responds. The green line is the set point of the controller. We can go back to 40%. We can stop now the data recording, and we can use this data set to develop a process model, estimate tuning parameters, and simulate the closed loop system performance. For documentation purposes, we can enter specific comments. Or we can link this data set to report files for documentation purposes. To start the tuning process, we need to choose a tuning methodology. Let us use the IMC tuning method. We can select the entire data set to develop a process model or a subsection of it. All data between these two red bar lines will be used to develop the process model. Now we can click on this button and perform the tuning. The modeling and tuning results are shown here. On the top right section of the plot, we see the modeling results. Let us click here. We see the changes we made to the controller output and the response of the process as indicated by the blue line. The red line is the model prediction. To To the left, we see the process gain, dead time, and time constant for this self-regulating process. It has been estimated that the accuracy of the model is good, which means that we can use it to tune the controller. The tuning parameters for this controller, according to the chosen methodology, tuning methodology, are shown here. In pink numbers, we can see the old tuning parameters. In the midsection of the screen, we see the response of the closed-loop system when we change the set point or when we introduce disturbances to the control loop. The blue line shows the response using the new tuning parameters. The pink line shows the response of the system when the old tuning parameters are used. Obviously, there is some improvement in the closed-loop system performance. If you would like to calculate the tuning parameters using a different methodology, come here, choose a different method. The tuning parameters have been re-estimated. The closed-loop system performance and robustness analysis have been updated. If you would like to perform if-then studies and see the effect of changes in the tuning parameters on closed-loop system performance, you can do this using the Simulate option. Let us copy the settings from the Tune page. As you can see here, we have the tuning parameters obtained using the PAS method. And up here we have the tuning parameters, the original old tuning parameters of the closed-loop system. We can enter, for example, a new tuning value for the proportional gain and the integral time, and see the effect on closed-loop system performance and robustness. To create a report which documents the tuning results, we click here. We can select what type of information to be included in the report. And then we can generate the report. The report can be saved in a file, a Word document file. And obviously we can use this report for reference later on. At any point in time, if we need help on how to use TuneWizard, we can click on this button and get help on a particular topic. For example, I can click here and get information on how to conduct a tuning test. I can click here and get information about process modeling. I can click here and see what is a hysteresis, how to do a hysteresis test, and so on. So at any point in time, the user can use the help section of the product to obtain very useful information on how to use it.